Okay, so here we are in the assignment, March 25th, the vocabulary of quadratic graphs. So again, we know the quadratic graph is kind of like a U shape when it opens up, when it starts at this vertex right here. So let me make this bigger. A few parts of it. One of the characteristics of a parabola is that when you split it in the middle, it's symmetric on both sides. What do I mean by that? So the middle would be a line extending from this starting point. This is probably the vertex. That point right there is the most important point because a lot of stuff relates to it or is based upon it. Now, if you look at that vertex, what would you guys say that is? I mean, what's the y? What's the x value of that vertex? So -3 is the x, right? And then what about the y? That kind of, yeah, because it goes by, it's like in the middle of the two blocks, isn't it? And the blocks go by -2. So yeah, I'd say -7. Okay, good. Okay, now the axis of symmetry is a line that vertically goes directly through the vertex. So I'm drawing a dashed line right there. Now, how do you list it? How do you list it or whatever? It's basically x is going to be equal to -3. It's also the same as the -3 on the vertex right there, right? But anywhere on that dashed line where it splits this thing in the middle, x is equal to 3, no matter how high we go up that dashed line. But the specific point on the parabola is going to be the vertex. Okay, so everybody clear on that part? It just splits it right in the middle. Okay. Maximum. Okay, there's basically going to be either a maximum point or a minimum point. When they say maximum, it's the y value that's anywhere on that graph. So like there's a y value right there. It looks like it's about 16. Oh, I should also talk about the fact, why do they call it the axis of symmetry? Okay, so let's take a point right here where I'm not on the graph, right? I'm not on the graph, but I'm on the axis of symmetry. And from that, the distance from there to there is going to be the same as the distance from there to there. Just like from here to here is the same as the distance from here to here. That's what they call symmetry. Like if there's two equal, if you cut something in half, like if our faces were symmetric, right? That would mean our right side of our face would be exactly like our left side of the face. And I don't know if you guys have ever done that, like where you can like show it. It looks weird, doesn't it? Most people aren't like perfectly symmetrical, their faces. But anyway, that's what it means by symmetry, and that line tells you exactly where the halfway point is, or the midway. Okay, now, maximum minimum refers to the y values. A parabola will either have a maximum point, a maximum y value, or a minimum y value. So this one here starts at this vertex, and then it opens up forever from then on both sides, to the left or to the right. It's like you're on a roller coaster, and you're at the very bottom at the vertex on this one. So this has a minimum because I can keep going up the parabola and I'm getting higher and higher values while still being on the graph. That means there's greater values of y than the vertex. So that means that's a minimum, and the minimum would be at y equals -7, which basically, by the way, comes from the y value of the vertex. You put y equals -7. So maximum would be, if it was one of these deals, it would be the top point, like the peak. It'd be like you're going on top or rising up the roller coaster and then coming back down. All right, so this one doesn't have a maximum, so you can just put NA for the answer if it doesn't have a maximum. If it didn't have a minimum, you put NA for the minimum. All right, any questions about that? Next, the zeros. What does that mean? Zeros are when the y is equal to 0. And when you have a quadratic equation, you can have 2 if it crosses the x-axis, meaning the value, what does it mean when the y is equal to 0? Well, up here, y, at that point, y would be about 16, right? And if I keep going lower and lower and lower, it's going to be a number until I finally get to the x-axis. And at this point and that point, y is equal to 0. So there's 2 of them. And it looks like it's at 0. Wait, no, it doesn't. Does it? Oh, yeah, obviously it does because it's going through the origin. So the zeros are going to be 0, 0 is 1. And the other one is -6, 0. Okay, -6, 0. Okay, so those are the zeros. And as you notice in both cases, the y's are 0. It just happens that the x is 0, but it doesn't always have to be. I mean, it could go through right there, right? You could go through at 4 and 8, and the zeros would be at 4 and 8. But in this case, ooh, tell me I didn't do something crazy there. What did I do? A video with a lot of information, but all right. So anyway, the y-intercepts, did I do that? Oh, no, we did the zeros. Okay, what's the y-intercept? Well, you guys know what the y-intercept is, right? It's where a graph goes through the y-axis. Well, in this case, the y-axis is also, the y-axis, where it goes through the y-axis is at 0. So that's going to be 0, 0, or y equals 0, either one. Yeah, sometimes it could be higher up. It could be like that, right? And then the y-intercept would be right there, 14 or 15 or whatever. Okay, but anyway, it's where it goes the y-axis. Domain. Okay, so domain for a general quadratic graph or function, if you don't limit it, remember, do you guys remember if the domain is the possible x values of a function or the possible y values? Do y'all remember? What does the domain represent? Possible x values or possible y values? There's a range and there's a domain. It means any possible point on this thing right here is considered a domain, and part of, if we're referring to the x value. So domain is like the x value range, right? And the range is what the possible y values are going to be. All right, so if we're doing domain, basically, unless there's something that limits it, on this graph, the picture you see of it, it stops when we get to about right there, right? But unless there's something that limits it, it's going to go forever, up and to the right. And if I go to the left side, it's going to go forever up and to the left. So there's nothing limiting it, and that would be all. I'm going to put ARN as an abbreviation for all real numbers. Probably going to be the answer for all of these on this assignment. But now the range is a little bit different. The range, if you start from the beginning is a vertex. From the beginning, it goes up. The graph goes up from the beginning, and it's going to go forever. But it doesn't go down forever, does it? It's got a minimum. So basically what it means is you need to identify where that minimum is if it's opening up. So in this case, the range is going to be, and the range again, remember, so you might want to put an x next to the domain and y next to the range. So the range would be y is greater than -7, because -7, it doesn't go any lower than that if you're no longer on the graph. But if you go to the left or to the right, you can get higher values of y forever. Okay, so that's what you would do. Now, for example, I'll do one more for you. So this one, the first one that you guys are going to do on your own, the range on this one would be, you now have a maximum, right? Looks like that's in the middle of 8 and 10, so that's probably going to be, the maximum is going to be y is equal to 9. But here, it's going to be, instead of it being y is greater than something, it's going to be y is less than 9. Probably actually y is less than or equal, because it can be 9, but it can't be anything greater. It can only be stuff less. A lot of students get confused on that. Are you guys okay on that? Probably once you get going on it, that you'll see how you understand it. Okay. Okay, opens up or down. Remember, I always think that the vertex is like the beginning. From the beginning, can we go up from there if we're staying on the graph, or do we go down? We go up, right? It's like you're in a roller coaster. You're at the bottom of one of those little curve, what do they call those? One of those, whatever. And now you're going to go back up the roller coaster. So this one opens up from the vertex, okay? The sign of A, okay? Well, we know that, right? The A, if it opens up, means that the sign is positive. You can just put a positive. If it opens down, it's negative. And finally, the C. What is the C? Well, the C is the y-intercept. So that's going to be 0. So like if we were going to write this equation down right here, see this generic, this is like the y equals mx plus b for a line. That would be the generic formula. for a quadratic equation, this is what they call the standard form. I've been showing you guys the vertex form because it makes it easy to do what we've been doing, but this is the standard form of the quadratic. What you'll notice on every form is there's going to be some kind of an x squared that comes out of it. The a is the same in every single case. And again, the a determines if it opens up or down, if it's positive or negative, and how wide or narrow it is. Okay, so that's a lot of stuff, right? So I'm going to keep going a little bit more because now that we've got this, we want to make sure we understand how to read it and get values from it. So this first one is saying, what is f of x if x is equal to 0? Well, I go where x is equal to 0, right there. And then I say, well, what's the value of y? Because remember, if you're doing functions, f of x is like the y, right? So if you ever see f of x, now you're thinking, is that f times x? No, it's like a function notation, and that's like the y. So kind of a review of functions. So basically, it's another way of saying, what is the y, if you want to put that down to keep it straight, if x is 0? Well, x is 0 right here, and it looks like y is also 0, so it'd just be 0. Now, the next part's a little bit trickier, at least in the beginning. Then it says, list any shown values of x if f of x or y is equal to 10. So there we have to go to 10, which I already did that. So here's this point here is where f of x or y is equal to 10 on the graph. So what is the value of x at that point? Well, it looks like it's about 2, doesn't it? Maybe it looks like a little bit off, but you can just put 2 close values. So it's saying that 2 is one of the x values right here, and -8. So those are going to be the values of x, where f of x is equal to 10. All right, so that's kind of it. Just a few quick things before I finish this up. There's going to be certain times when you may not have zeros. If I had we could have a quadratic like this, and it doesn't have any zeros because it would have to go through this x-axis to have zeros. It doesn't, right? So you can just put not NA for not applicable if it's a situation like that. I don't think any of these are like that. I think I made it so that these have zeros. Yeah. But just so you're aware, not every parabola is going to have zeros. And so I think that's it. Any questions? Good stuff.